Good afternoon. My name is Neguine Rezaii, and I'm an instructor of neurology at Harvard Medical School. Today's talk is about the direct use of language by natural language processing models for the purposes of diagnosis and prediction of psychiatric disorders. So this approach would be a little bit different from a more common approach, which is extraction of clinical data from electronic health records, or EHR, another very helpful topic, but this talk concerns the direct use of language. Schematically and ideally, what we want to happen is for a patient to talk at a clinical setting. This conversation can be a very casual conversation, or it could be through a structured clinical interview, or asking the patient to describe a picture. The language will then directly used to feed a neural network depending on the purpose. It could be different type of natural language processing models for different purposes. I'm going to focus on a few of these, and then the output of the NLP model will be transferred to the physician in order to make a more precise diagnosis. But why language? Here, I first want to establish why language as a behavioral output is replete with layers upon layers of information. Imagine we first start with the most straightforward type of message, which is the direct message that we convey. Imagine you just say that you've got stomachache. So what happens is that the pain receptors or nociceptors in stomach transfer the data to the dorsal horn of the spinal cord. From there, it goes up there to the brainstem, from there to the thalamus, and from there to the specific areas in the cortical regions and also the forebrain. So you can argue that the language network in the brain has an indirect access to what is happening in the stomach, and by the same token, to a wide variety of neural networks in our bodies. Sometimes the message is not so direct. Imagine that the pain is not so specific yet to be localized in a specific organ. You just feel it as a very vague discomfort somewhere in your body. However, the particular choice of your words, word order, even the acoustic features of your language will be different when you're in a vague discomfort when compared to the times that you're absolutely normal. So we can say that language basically contains information about the functional status of our body, both mentally and physically. We can also find some subliminal information in language. I'm going to refer to a study, now a classic study that was done by psychologists at Yale University, published in 2008 in Science, when the participants were asked to hold a cup. It either contained a hot coffee or cold coffee. The subjects were not aware of the design of this study, but they were just asked to describe the personality of the person that you just met, a researcher, basically. Without the participants being aware of what was going on, if they were holding a warm cup at the beginning, they would describe the personality of that individual as warm, caring, generous, on the dimension of warmth. And if they held a cold coffee, they would have more negative description. So you can say that the language of the person would have information about the temperature that the participant was exposed to. Then it would be a case of reverse engineering, how we can go from language to the mental state. However, these signals can be so subtle in the language that could be very difficult for the naked ear to hear it. We also require a lot of data that is impossible for a human observer to extract this type of information. However, NLP models now enable us to be able to extract subliminal, indirect, and also the direct message from language. Here I'm going to focus on 3 applications of use of NLP in psychiatry in order to improve diagnosis and prediction of mental disorders. So the first one is making subjective objective. We as clinicians learn to pick up on many features from the behavior of our patients. the way, from their hand gestures, from their voice, from their facial expressions, silences. But mostly we just write down what's going on in a qualitative manner, which makes it vulnerable to all sorts of biases and inconsistencies across time, across different clinicians. But is there a way to make these subjective measures more objective? I'm going to focus on semantic density. By that, I mean the amount of richness of the information that a patient conveys to you after they talk. It has happened to us a lot that we sit with a patient for about 1 hour, and after we leave the room, we just don't know what went on. We want to write down about what happened, but the language of that patient boils down to almost nothing, because the language is so incoherent that the dots simply do not connect. Let's focus on these two examples. I will tell you where these sentences are coming from. I think I do have strong feelings for politics. So you cannot, well, actually I'm supreme, nobody will not try me. These are two sentences from two adolescents from a study that is called NAPLES, North American Prodromal Longitudinal Study, that has 5 centers in the United States. And they collect data, language data, from adolescents who are at the high risk of developing schizophrenia because they have a first-degree relative with schizophrenia. Briefly, schizophrenia is a serious mental disorder in which the patient may have auditory hallucinations, false beliefs or delusions, disorganized thought, disorganized behavior, and something that we call negative symptoms, meaning that they just sit down and do nothing. They do not initiate conversation. They do not act on anything. So here the question, at this point, everybody was normal, not converted to psychosis. We followed these individuals for 2 years and asked whether we could predict who will convert to psychosis in about 2 years. In order to have a quantitative measure of semantic density, we used word2vec that was developed in 2013 by Mikolov. Here, as many of you are familiar with this method, here we're focusing on the word lucky. This method gets the neighboring words of the intended word lucky in this case and produces a very large matrix of the co-occurrence of one word with all the words that it co-appears. The window may differ from 1 word to 5 words. Here it was 5 words. For this study, we used 25 years of text from the New York Times, about 43 million sentences, to create this space. This space is a 3-dimensional representation of a 202-dimensional space. Each dot is 1 word, color-coded for part of speech. Words that tend to co-occur with a higher probability are closer to each other in that space. Again, the colors represent part of speech. Blue is noun, most common part of speech in English, and red is verb, and so on. So when we transformed words to vectors like this one, so lucky would look like this, then we can do all sorts of operations on it: multiplication, subtraction, addition. A lot of it is just experimental because the field was so new at the time that we were not quite sure what would multiplication of 2 vectors mean semantically. Is there any application for that? Something that has been used in psychiatry from LSA, 1 generation before word2vec, was just to add the word vectors associated with each word. Here we've got the sentence, something strange happened today. So something is associated with 1 vector, strange similarity is associated with 1 vector, so on. And finally, we can summarize the entire sentence by adding the word vectors associated with this sentence. This has been used in other studies, and here we asked, okay, so there is not only 1 way of getting at this sentence vector. There should be other ways of adding vectors in that 202-dimensional space in order to get at this sentence vector. But what is the minimum number of vectors required to reconstruct the same sentence vector? We tested that And we call these minimum numbers of vectors to reconstruct the original sentence as component vectors. So we found that a sentence that is rich in meaning would have almost the same number of component vectors as the number of words. So we defined semantic density as the number of component vectors, the red ones, divided by the number of words. For this case, we have 3/4, which would be 0.75. But what does that mean in real life in psychiatry? Then we looked at the sentences produced by the individuals who were at high risk of developing psychosis. Let's take a look at a few examples. Well, I think I do have strong feelings for politics. Not a bad sentence semantically. For this one, we got the max, so it varies from 0 to 1, and we got a semantic density of 1. I mean, it seems like as much as we want to believe we matter in universe, I don't think there is really anything that suggests that we do. This one was from an adolescent, very philosophically minded individual. For this sentence, we got a semantic density score of 0.93. Sometimes I get nervous and I get worried about time and I can't look at the clock. For this, we got semantic density of 0.62. When we took a look at the sentence, we found that, oh, some overlapping meaning is going on here. I get nervous and I get worried basically mean the same thing. So we need less number of component vectors in order to reconstruct the sentence vector. And finally, this sentence that we read before, so you cannot, well, actually, I'm supreme, nobody will not try me. For this one, we got a semantic density of 0.14. We actually ran another supplementary analysis. We asked the participants from Amazon Turk, a platform to collect data from human participants, and had a strong correlation between the machine learning scoring of semantic density and human judges, and also similarly we asked some of the clinicians to do the same. But still, okay, we've got a measure of semantic density that is more objective than just rating it from 0 to 10. But in application, we found that after 2 years of following up the individuals, semantic density could predict conversions to psychosis with 80% accuracy. Here we used a logistical binary regression, and I don't know if you see the cursor. Yeah, you do. So here are the true positives and true negatives, and these are the false negatives. So we got an accuracy of 80%. The second application is discovering symptoms that are easily missed. This one is one of my favorite applications of NLP in psychiatry, because psychoanalysis and other disciplines in psychiatry has long wanted to extract the hidden meaning from a patient's language or reading between lines. But this has been done in a very subjective manner. So is there a way to extract meaning that is not directly said by the participants? Let's go back to the sentence that we talked about. Something strange happened today. You're familiar with this concept, but briefly I'm going to talk about cosine similarity. If you want to compare the similarity of two sentences, you can simply measure the cosine of the angle between the two vectors, sentence vectors. You can do the same thing by measuring the cosine of the angle between the sentence vector and a word. For instance, the word shiny. It's not really semantically close to this sentence. So the cosine of the angle of these two vectors were 0.2. However, a word like creepy is semantically closer to this sentence. So for this, we got a cosine similarity of 0.7. So what we did was we listed all the words in English and listed all the sentences from the participants of this study, and just asked what words best represent or have the highest cosine similarity with the sentences produced by these individuals. Here's the space. So a lot of it actually reflects the nature of the interview. It was a structured clinical interview, so you see a lot of time because the subjects were asked, okay, when did that symptom start? So you see a lot of time. But the one region here that was specific to the individuals who converted to psychosis was this area. Take a look here. So we have words like voice, loud, sound, utter, whisper, hear. What's going on here? A lot of auditory, perceptual processing words. So what does that mean? One of the prominent symptoms of schizophrenia is auditory hallucination, abnormal auditory processing. So we asked, okay, what were those sentences that resulted in this region? Let's take a look. So these sentences that I'm going to read to you had a high cosine similarity with word whisper or utter. And what is important is that the word whisper was not used by any of the participants of this study. The sentence only had a high cosine similarity with the word whisper. You know, I talk to myself, but I don't know if it is me. I mean, I talk to myself in the mirror. You know, I'm talking to me, but how can I have a conversation with myself? I say stuff in my head as if I'm talking to me, and it's funny, and I laugh like I didn't know what I was going to say. This is a very typical but rarely found symptom when an individual is very gradually transitioning toward having auditory hallucination. The stages of auditory hallucination is that first, the participant does not know, the individual does not know whether it is their thought getting a little bit louder or is it actual voice. When it gets more prominent, they actually turn back and look for the source of the voice. Through time, it's sad, but the patients learn to suppress themselves because they get negative feedbacks from others around whenever they talk back to the voices that are not there. So some of them learn to suppress talking back to the voices, but when it gets very severe and during the acute stages, they just talk to the voice. So here you see that transitional period when the individual is having, these are the last moments of having insight, what's going on. He talks later more about it, and he asks a question that I still do not have any answer for. He asks, how can my mind tell me a joke that I have never heard and actually laugh? How can my mind synthesize something that I've never heard of and still laugh at it? The other sentence was, I would hear something that sounded like a plane engine or like really, a really far off motor. It never went away entirely. It's gone a lot more in the past couple of months since Christmas. It just sounds like that. It sounds like a flame or a cellular, a digital motor. Here, as you see, there are all sorts of wrong associations. Sound and a little flame. You do not expect a little flame to really have sound, but that participant was hearing sounds from objects that do not produce any sounds. Unfortunately, both of these individuals developed psychosis after 2 years. So then we asked, what about predicting conversion to schizophrenia using these vectors reference to voice? And with only that variable, we found a accuracy of 83.3% in predicting future onset of schizophrenia using reference to voice. When we added the two variables, semantic density and reference to voice, in a single regression, we got the accuracy of 93%. We reproduced the same results after doing holdout cross-validation. The last application that I'm going to talk about is classification of diseases. In psychiatry, classification of diseases is very challenging, because for the majority of disciplines in medicine, we have got a robust background about the pathology. For instance, if it is a liver cirrhosis, you just do a biopsy, measure the amount of protein that is there, and with very high certainty, you say it is liver fibrosis or cirrhosis, because it is pathology-based. We've got the molecular biomarkers for that. Unfortunately, in psychiatry, I find it a very interesting feature of psychiatry because the brain is so complicated. The case is that you can have the most severe mental disorder, the treatment-resistant depression, or you can have very serious and severe schizophrenia with a brain MRI that is absolutely normal. You look for everything, blood biomarkers, everything comes back normal. So classification becomes very difficult and very challenging. So far, we've been using the DSM, the Diagnostic and Statistical Manual of Mental Disorder, which is a very heavy textbook based on consensus of clinicians deciding that the combination of this and that symptom is disease A. And from one edition to the other, these descriptions and definitions vary. So here it's very important to have a method that makes the classification more objective until we have more solid biomarkers similar to pathology. Sometimes, so there are two cases. One would be theory-driven approaches. In that case, the outcome of a disease is very clear. Rarely happens in psychiatry, but there is one very clear case, which is acting on suicidal thoughts. So acting on suicidal thoughts is an unambiguous disease outcome. Either a person does it or not. There is no subjectivity there. So, but prediction of suicide has been a challenge in psychiatry. There has been some promising research showing that using a combination up to 100 features of linguistic features and vocal characteristics of an individual, most of them went to ER and their language were analyzed. It shows with about 80% of accuracy they can predict who will commit suicide. And again, the number of these features are beyond what a clinician can do or can extract from a patient's language. We also have data-driven approaches. Sometimes the symptoms of a disease is very clear, but the disease categories are not so clear. The example would be auditory hallucination. It's pretty clear when you see an individual having auditory hallucination. They talk back to the voices, and you see what we call responding to inner stimuli. So it's also a clear symptom, but the disease category can be challenging. Is it schizophrenia? Is it schizoaffective disorder? Is it bipolar disorder with psychotic features? So the disease categories become challenging. Here again, natural language processing models can help us have a more objective way of classifying the diseases by just measuring the ways in which the language of participants are similar to each other. We can find the natural clusters in the language of the participants. And one study that was used in 2017 by Hoffman showed that was in the case of primary progressive aphasia. This is one of the early stages of developing either Alzheimer's disease or frontotemporal dementia. So there are neurodegenerative disorders, but in some cases, the patient can only have language problems with everything else remaining intact. They could be university professors, everything is there, they function okay, they just cannot talk anymore. So, or they lose their syntax is gone, their semantics is gone. Hoffman used data-driven approaches from NLP to classify the language of patients with primary progressive aphasia to see how they cluster. After that, you can do pathology analysis because for this particular case, we actually do have some pathological biomarkers. Again, as I said, this approach would be particularly of value in psychiatry where the unifying disease classification theories are still evolving. Finally, the conclusion slide. In this talk, I wanted to show that language is replete with information, layers upon layers of information about mental and psychological states of a participant. This information can go beyond what the patient directly conveys to the receiver. Natural advances in natural language processing models can make it possible to extract the latent indicators of mental illness to improve diagnosis and prediction of neuropsychiatric disorders. Thank you so much.
Thank you very much.
Sure.
So we have quite some time for questions. question number one. Secondly, from everything we have seen so far, most of the models are actually not working with them. They have very low specificity from the confusion matrices that we saw, and very, very low recall too, right? Accuracy is completely dependent, of course, on the data set itself, right? So my concern, overall question is, are we, is this the right direction to go in at all? Because from what I've seen, I'm a natural language processing data scientist, and I also suffer from mental health issues, right? And when I see something like this, what it does is actually it scares me, because I can clearly see that there is some problems here.
Sure. So that's the purpose of having these types of talks, to talk about these potential problems. So about why New York Times? First of all, we replicated that study by using different types of corpuses. We also used Reddit because we thought that maybe it is closer to casual languages that the participants use. We also used Switchboard, which is a transcription of the telephone conversation, so it is very casual. So with all three, we got the same results. It is in the supplemental of that paper. So yeah, we are still in the exploratory phase, so we do not know. Why we started with New York Times? Because we had the largest amount of data on that corpus. Switchboard has about 1,000 less words when compared to New York Times, so it is less accurate. But for the measures that we used, it had very comparable variables when we compared Switchboard and New York Times. So the study was replicated across different English corpora. We did not use any other languages because the participants of this study were English speakers, so that's a good question. Can we replicate that in totally different language? That I don't know. It's interesting to explore, but the three corpora replicated this part. And the second question that you had about low specificity, so I agree with you, it is not perfect. But please bear in mind that what we're talking about in real life is chance level. When the clinicians of that study were asked to rate how much abnormal auditory processing, and these are they're trained clinicians. They take courses after courses in order to be sensitive about the patient's language. When we use the ratings of the clinicians to predict future onset of psychosis, we got a chance level. So the machine learning is allowing above chance level. It's not perfect, absolutely it's not, but it's for the first time we're having some predictions about future. These are very early work, and I'm very optimistic about future. So there are going to be more accurate ways of testing that. This one was on word2vec. Now we've got a lot more nuanced and sophisticated neural networks NLP models that we can use and test if the accuracy is higher than what we presented. But I think the fact that we're going beyond chance level on its own is promising. Yes, please.
Fair enough, but based on researchers, that's not the case these days. So many researchers has found that the NLP model producing a biased representations, or very sometimes gender bias or race bias, the representation of the word. So I found that because the thinking about like the potential impact of this work is much serious than just building a biased recommender system or just search system. So my question is, do you found any potential risk, or how could you address that kind of risk of this work?
Sure, yeah, so this one was vector-based. There are, now I am using BERT, the more recent, relatively recent, the field is moving on very quickly, the relatively recent natural language processing model. And the biases are there, absolutely. We actually tested, some of the answers are very sad. Actually, a lot of these models are very racist or even sexist when you ask, when you find a trend, just look at the trend of text. The order of mother and father has changed recently over the past few decades, meaning that they're prioritizing women. But older text is male dominant. So it really depends on the corpus that you're using, on the timing of the corpus that you're using. It is vulnerable to biases, absolutely. And that's why I think one method to address that is to use different types of corpuses, because potentially they might have different types of biases embedded in it. There have been research comparing old and new corpora, and the focus is more on the more recent texts, but there are methods in a new paper that a group published at British Journal of Psychiatry was just talking about these biases. Are there ways to detoxify the corpus? Potentially, NLP models can be trained to detect certain types of biases, like the ones that I mentioned. Are they able to automatically flag, just like the way you flag syntactic error or spelling error in writing? Are there ways for natural language processing to flag these types of biases of various type automatically? That's a possibility. Yes, please.
You know, in psychology here, you're based on language analysis, whereas in normal physiological... Is it okay?
Yes.
And we were speaking about biomarkers, like in physiological medicine, a broken bone is a broken bone for every culture, but you're based on language, and language is something learned, and depending on cultures. So what are your thoughts about how generalizable these findings are in the view of the fact that you're based on something which is actually culturally learned rather than physiological?
Yeah, so the generalizability is something that is applicable to any field in medicine, right? So for the study that was done on suicide, it was from a group, Pestion 2017, they started it, but I know that more recently they have validated the same result. They replicated that across 7 different centers, still across the United States, but there are studies going on to make it multicultural, as it was spoken earlier in this talk, that we need to have a multilingual approach to analysis of language. So these have to be replicated in variety of languages, variety of cultures. What I can tell you at this point is that at multiple centers, some of these studies have been replicated. The one about semantic density has been replicated, and the one about suicidal thoughts has been replicated, but across other cultures, other languages, not yet. Again, the field is evolving, so this is just the beginning, maybe the first step, but these are what you're mentioning are all the right directions that the field has to go.
Hi. I found the work on predictive conversion to schizophrenia very, very interesting. And the 2 experiments that you've included, the one with the semantic density and the one with proximity to the voice-related cluster, they seem to be, in a way, constraining the freedom of the system to find its own features, which is kind of the more fashionable approach these days. So have you looked at these kind of networks that you allow them, you just give them the input and allow them to find what it is that contains the signal in the data, rather than focusing its attention to either one cluster of words or semantic density? So have you looked at kind of more degrees of freedom for the AI system?
You mean so everything was cross-validated on a holdout set, so it was not specific to that data set. So
no, what I'm talking about is the fact that you seem to be using expert knowledge to choose what are the features. rather than allowing the system to find its own features, which is what a lot of deep learning is doing these days.
Right, yeah, you're absolutely right. So that will go to the third part of this talk that was more data-driven. You're right, this was kind of hand engineering the features that we were looking for. You're absolutely right. No, these were, because we did not have any objective measures for semantic density nor for latent content, but these were very important features in a variety of psychiatric disorders. Our aim was to hand engineer the important or the cardinal symptoms of psychosis, but it would be very interesting to find out what the data will tell us without us training it towards a certain feature. You're right, yeah.
Hi.
Hi.
I come from a different type of background, so my question would be slightly different. I share whatever the ethical part of your presentation and the concerns. I'm just wondering, you did not put enough context. What's the chance prediction? So accuracy does not really allow us to appreciate whether there was an improvement or not. So have you predicted always, yes, he will be suicidal, or no, he will not be? How much better does your method do?
With the vocal...
Any of these. So you said that it improves chance prediction. How much does it improve it?
So that model, they did not provide specific data. So there's one study by Betty. They used other features they used another way of measuring coherence. So they, unfortunately, they had only the final regression and did not have the standard normalized weights to know which of them had a more important part. So they had a bunch of features, acoustic features, semantic features, syntactic features, and with a collection of these, they made a prediction. So to what extent each of these variables played a role, it was not specified in that article.
Thanks. Thanks for your talk. Very interesting because I did work on NLP for, let's say, leadership and charisma previously. A couple of my people here sort of touched upon the question. My question to you is, I have two questions. So first question, can you sort of give a little more details about the data set? How many people were there? Sort of the other demographics, male, female. I know they are adolescents, but still, that's one. Second question, yes, you used word-to-vec, but in my experience, when it comes to such situations, something more old school, TF-IDF does a much better job. So my question is, did you try that?
We actually did, yeah, in order to specify, sorry, I'm just answering it backwards from your second question. So yes, we did actually, and in order to specify which word was more important for the second part of the talk, to find the latent content, we did that, sure. But in order to have vector representation of each word, we used word-to-vec. And about the first part of your question, Naples is a very large study, nationwide study, and there are multiple centers in the United States. Not all centers do audio-video recording of their individuals. There are, as far as I know, they're now at the phase 3, Naples 3. We got data from Naples 2. And only the site at Emory University, Yale also had a site, but none of them recorded voice and audio and video of the participants. So we just took advantage of what was available. We got 40 video recordings of the participants as they were sitting with a clinician and talking through a structured interview with a clinician and transcribe their language and use that. So female to male was almost the same, 1-to-1, and the age average, if I'm not mistaken, was 17. But the range, I think the youngest was 13 and the oldest was 27.
Wouldn't there be like a difference in terms of language usage because they grew older? Because let's say a 13-year-old, the way they speak to a 27-year-old will differ a lot.
That's something else to put in the regression. So developmentally, usually the language, yeah, so you can.
From a science perspective.
Right.
Data science perspective, but from a medical perspective, does that play a role?
Well, unless it is evaluated, we cannot tell, but I work with geriatric patients, and the language is very comparable to young adults. So, but if it is generalizable to a teenager, that needs to be explored.
Thank you.
Sure.
Thanks. My question maybe relates to your question. And often it's a problem that the data sets actually in numbers are small. I understood it's 40, and so you need to do some feature engineering count learning. And I think there would be a huge potential if there were not 40 but 40,000 data sets.
Yeah,
do you have any creative ideas or how this data situation could be improved?
Right. So this is emerging science, and we are hoping multiple centers to work with each other. Unfortunately, our foot are on the solid ground of reality. What is really feasible? Getting even 40 data sets from schizophrenia patients is not easy at all. And Naples 2 was one of the largest that had that type of information. This study, when I started, was in 2015, so it's getting better. The numbers are getting larger, but still in the orders of 100. I know data scientists work with millions and like thousands of participants. This is not really feasible in medicine, have that amount of data from participants, but what is promising and the good news is that multiple centers are working with each other to have a larger cohort of participants.
I'm sorry, there's a question here.
So thanks a lot for the interesting talk. My question is a bit more about the patients themselves. I can imagine if someone, for example, suffers from other mental health symptoms like, let's say, multiple personality disorder or something like that, they might have, let's say, switching regime or context as they talk. I just wondered if you encountered these kind of, let's say, issues, or if all of the patients were, let's say, mainly diagnosed for the specific disease that they were included in the study for.
Right. So about multiple personality disorder, it's interesting. It goes back to my earlier point that from DSM to DSM, it changes. So no longer DSM, Diagnostic and Statistical Manual of Mental Disorder, acknowledges a condition called a multiple personality disorder. But if you go back to older texts, that was the fashionable diagnosis. Everybody had multiple personality disorder. So that was not something included in the screening. But most of the participants before before converting to psychosis were pretty stable. It's interesting. That's a very good question, actually. We are now doing a longitudinal study, and the majority of patients are pretty consistent in terms of the semantic and syntactic features of their language from setting to setting. So they were pretty stable in that regard.
Then thanks again to the speaker for this very interesting talk and discussion.